So here are my goals for this little mini lecture. So I'm going to go over the monomers and polymers of organic molecules. I'm only going to focus on carbohydrates, lipids, and proteins here, but we also have nucleic acids and the role that they play in RNA and DNA. And what I want to do is layer in those concepts to these. So I want to talk about anabolic versus catabolic reactions. And I want to relate those terms to hydrolysis and dehydration, as well as to the terms synthesis and decomposition. So I want you to feel comfortable using those terms for different reactions interchangeably. Note that dehydration, if you learn the term condensation, those are one and the same. So starting with this organic molecules, so you've got your monomers listed over here and your polymers. And a lot of this is review, right? So if a protein is broken down, you're going to get amino acids. So another way of saying that is amino acids form to make proteins. If you take a fat like oil or omega-3s and you were to look at the composition of those molecules, you're dealing with triglycerides, and what you end up getting is a glycerol backbone with 3 fatty acid tails coming off of it. So those are the monomers of triglycerides. It's not just one, but it's actually both glycerol as well as these fatty acids. And then last of these organic molecules are your carbohydrates. So with the polymers, I went ahead and put polysaccharides here. So poly, that root word meaning many, and mono meaning one. Sac means sugar. And so in addition, what I haven't listed is the intermediate here, which are your disaccharides. I would like you to be familiar with 3 examples for each of these. So with the monosaccharides, the ones you should know are going to be glucose, so classic blood sugar, fructose, which is found in fruits and honey, and then the last of those is galactose. With the disaccharide, you've got your sucrose, which is actually a glucose plus a fructose. You have your lactose, which is going to be glucose plus galactose. And that's what's found in milk, right? So you see the root word lact. And then lastly, you have maltose, which is the basic sugar found in malt used to make beer, etc. So those are the 3 disaccharides. And with the polysaccharides, you have your starch. So this is the storage form of sugar in plants. The corollary of that in humans is glycogen. So if you think about a potato, right, or a blueberry or a banana or any other fruit or vegetable, that starch is that plant's way of storing glucose, that monosaccharide. With glycogen, we store glucose in our own bodies, in our liver, as well as in our muscles, but we store that in the form of glycogen. Another major polysaccharide that I'd like you to know is cellulose. So I apologize for the busyness, but again, the polysaccharides are starch, glycogen, and cellulose. And so you can combine these monosaccharides to make disaccharides, and you can combine disaccharides with monosaccharides to get your polysaccharides. So let's clean this up and take a look at how these terms relate. And what I want to do is layer in these terms. And so if you look at an anabolic reaction, so anabolic is something that builds. So anabolic steroids, for example, right? So that is the building of muscle. Synthesis, so you are synthesizing or creating something, that is also going to relate to this term anabolic. And so what I sometimes like to do is to think about these terms as all building. So you'd have your polymers up here, and you'd have your monomers down here. So anytime you want to take a monomer and make a polymer out of it, you are going to be looking at an anabolic reaction. That anabolic reaction is going to include a dehydration reaction. More on this in a second. And you're synthesizing something. Conversely, if you're taking a polymer, let's say we have glycogen stored in our liver and our muscles, and we're in a fasted state and we need to break that down to get blood glucose. Well, what you're going to do is you're going to undergo a catabolic reaction. You're decomposition of that glycogen to get your glucose. And it is going to be a hydrolysis reaction. Up top, these are the dehydration synthesis reactions, and these are the hydrolysis. This is shown as hydrolysis reactions. So with dehydration, what you're essentially doing is you're taking two monomers, you are losing a water, and when the OH and the H combine to release that water, look what happens. You actually get a covalent bond that links those two monomers. So an example of this would be your glucose and fructose coming together to make a sucrose molecule. And I can flip that down here. So in a hydrolysis reaction, so you're decomposing, it's also catabolic. We could take our sucrose, we are splitting water. So water, lysis to split. So we are splitting that water molecule, and as a consequence, you get our two monomers. And so again, you've got glucose and fructose. And again, that's just one example of many. I could have also said that we've got two amino acids here, and we're making a protein. It would be a very, very simple protein, but nevertheless, you could combine those amino acids to make a protein, and then vice versa. Come back here and see if we can layer in these terms. So going from monomer, going from our amino acids to protein, right? This is going to be anabolic. And conversely, going the other way, it's catabolic. And right, we could also have described anabolic as synthesis reaction or as dehydration, right? And the same thing here with the glycerol and fatty acids. When you combine those to make triglycerides, that's going to be anabolic. And when you reverse that, catabolic. Just for kicks, let's change up the phrases here so you can see how much they relate. So if we go from monosaccharides to polysaccharides, that's going to be dehydration. Or you could say a synthesis reaction. And then on the flip side, if we go take a polysaccharide, if we have starch and break it down to its monosaccharides, its sugars, you can call this a hydrolysis reaction or a decomposition reaction. Hopefully layering in those chemical reactions with the key monomers and polymers that you need to know is useful and helps you to see the big picture. Of course, there are countless examples from a dietary standpoint, right? So when we break down eggs from breakfast, our digestive system breaks it down into amino acids, and then our body reassembles those amino acids into whatever proteins we need to make. Maybe that's enzymes for further digestion, maybe it's proteins for your hair or your skin or muscles. If we break down stored fats in our body, we can get glycerol to be released from that as well as those fatty acids. And I already gave some examples from a dietary standpoint for the carbohydrates.